Hi all. So today let us discuss about a case study related to proximity sensors. So first you know that what is proximity sensor. So it is a device which is used to detect an object, presence of an object. Okay, it is used in say various applications like in industries for say automation and in safety it is used for activating the automatic doors it is used and for giving security alarms. So like this for many applications we can use the proximity sensors. So it is detecting the presence or absence of an object without any physical contact with the object. That is very important thing in this proximity sensor. Okay, so let us see a case study on proximity sensors used how it is used as a accelerometer and vibration sensor. Okay, I'll give you a few minutes for discussing among yourselves. So you discuss and let us share the points with each other. Okay, so you start your discussion. Discussed among yourselves. So let us start to share the points. Who's going to start first?
So let me give the literature review of this proximity sensors. In traditional method, the accelerometer was it is very bulky and mechanical. So worked by using the mechanical deflections, and because it is but it is very less sensitive, and it is slower in response. But in modern approaches, the accelerometer uses the proximity based deflection, because it makes them very compact and highly precise, and then it is very cost effective also. But in traditional method, the vibration sensor, it commonly used the proximity piezoelectric sensors, because it needs a non-contact. It needs a contact, and but in modern approaches, in vibration sensors, they are using the proximity based methods, mostly preferred that, because it increases the durability, and also it is cost effective also. So.
I'm here to say the working principle of proximity sensors. And there are three types of proximity sensors. First one is inductive, and second one is capacitive, and third one is photoresistive. Inductive is the main thing in proximity sensor capacitance. For example, inductive is nothing but it detects the metal objects, and capacitive sensor detects the non-metal objects. And the third one is photoresistive. Photoresistive is nothing but it detects the long-range distance metal objects. The working principle of inductive sensors is nothing but it has some main parts like DC supply, oscillator, and then switching circuits and output amplifier. The first thing is the DC supply is converted into AC supply with the help of oscillator, and the AC supply is sent to the voltage regulator, because the AC supply can be sent directly through the voltage regulator. With the help of a voltage regulator, we can regulate the voltage levels. After regulating the voltage level, it's sent to the core. It's nothing but in the core it produces the eddy current. The eddy current produces from this direction, and the AC supply produces from this direction. While coming from this side, eddy current, and this side is AC supply. While colliding, it will give some jerk. The jerk is carried and it's sent to the switching circuit. The switching circuit is if it is jerked, means it will be turned on. While turning on the circuit, the sensors detects some jerks have been detected. So the sensors can detect the metal objects have been detected. While detecting the metal objects, the detected objects will be sent to the output amplifier. The output amplifier is nothing but it converts the weak signal into high signal. By converting the weak signal to high signal, the metal objects can be detected very easily.
Okay, next who's going?
So I'm going to explain the core concept of this case study. So main concept of this case study is how proximity sensor works in accelerometer and vibration sensor. So I'm going to explain how proximity sensor works in accelerometer. So it's basically works on the principle of capacitive proximity sensor. Why? Because we use capacitive proximity sensor. Because proximity sensor only detects the metallic and non-metallic objects. So its applications are everywhere. We can use in our day-to-day life smartphones. It activates the auto rotation and gaming consoles. So and next one is car crash detection. It activates the airbag. And the next main thing is in drones. Drones it's stabilization and navigation. And next one is medical. In medical, it activates the heart rate and ESG. So that's all, etc. So it is very low cost with high sensitivity, and it is used in small industries.
Okay, next who's going? So just like Mayapin told, the proximity sensors are used as accelerometers. So now I'm going to be talking about how the proximity sensors are also used as the vibration sensors. So proximity sensors can actually detect tiny displacements, that is vibration. Whenever there's a system vibrates, it can actually detect it not without the contact from it. So this proximity sensor as vibration sensor can actually measure the amplitude, frequency, and also the shaft displacement. So if we are just seeing how it works, means if we are having a motor that is in a rotational format, like when it rotates, we will keep the proximity sensors close to it, not together. We just don't use it by joining it together. We'll just keep it close. That's the main point of it, because it can detect the vibration even without having the direct contact with it. Just because we keep it close, it can actually detect it. So when the system rotates, the system moves back and forth. So of course, when it moves back and forth, the distance between the system and the sensor will vary. So that distance will convert it to the electrical signal, and from that electrical signal, we will get the vibration displacement. And engineers will actually analyze that signal from how the amplitude of the vibration have varied, the frequency, and also displacement, and from that they will get the best output. So this is all about the working of it, and this will be very helpful in the civic structures like in bridges and all of the buildings and all of that. And it's very useful for the harsh environment where the temperature is very high. If the pressure is very high in the industries, it can actually help, because we'll keep the sensor outside of it, not together. So if just because we are having the sensors outside, the sensor will not get affected or get rusted. So this will become a very good solution for our problem. Okay, next.
So while coming to the advantages and disadvantages, the main advantage is that high accuracy measurement for the microscale displacement, and it works well in the harsh industrial environment and also in the high speed, and it is compatible and suitable with the integration of the IoT systems. And while coming to the disadvantages, it is high cost and it needs calibration after each application, and it is get affected by temperature, humidity, and EM.
Okay, who's going to conclude?
So I'm going to conclude this topic. So we all know that proximity sensor plays a vital role in accelerometer and vibration sensors. So proximity sensor can measure a small movement of an object without touching it. So it makes them more reliable and long lasting. So they are mostly used in safety monitors like airbags in cars. Then in machine monitoring like in machines and motors. They are mostly used in smartphones, cars, airplanes, and in industries. So the future scope of the proximity sensors are they can be connected with IoT and can be used for real-time monitorings. Then the artificial intelligence are interconnected with them to find the fault before the fault occurs. Next, in future, the nano sensors will be created. Through the nano sensors, the accelerometers will be more sensitive and more reliable. Then they are most widely will be used in buildings, in safety monitoring systems, and in wearable devices.
Okay, thank you for sharing your points. Thank you very much.
Thank you.
Thank you, ma'am.